Hello, everybody. Thank you for coming. This is, as Shannon mentioned, the open forum on Fair OS for Learning. The subtitle is Integrating Fair Principles and Open Practices to Address Shared Societal Challenges. So, this is meant to be very open conversation, but I thought I'd maybe, or Sam and I thought we could maybe lay the groundwork a bit and just have a few slides here to basically tell you what we're talking about. And then we can jump into the questions. So hopefully this won't take too long. And again, at any time, please feel free. I have my eye on the chat. I think Sam probably does too. Or you can just unmute and pipe in at any time, please. So back in 2016, there was this article published by Wilkinson et al. Called The Fair Guiding Principles for Scientific Data Management and Stewardship. They're a set of principles to ensure that data are shared in a way that enables and enhances reuse by humans and machines. And I will say that this fair principles, when they say data, they mean that pretty broadly to include research products, education products, science data, and software as well, computational tools. So they have it pretty broadly. But the main, the FAIR stands for, the F is for findable, which is defined as metadata and data should be easy to find for both humans and computers. Accessible for the A, the exact conditions under which the data is accessible should be provided in such a way that humans and machines can understand them. Interoperable, where the metadata should be based on standardized vocabularies, ontologies, thesauri, etc., so that it integrates with existing applications or workflows. So basically works well with others. And then reusable, metadata and data should be well described so that they can be replicated and or combined in different research settings. And of course, each of these at the larger grain level, but they have even finer points here, things that the principles rely on. I'm not going to go through all of them, but just so you have them in the slides and you can see them here. If you go to the article, you'll see them there as well. And so, one of the things that these have been actually even before 2016 have been in development for quite a while now. And as at some level, a mature level, where it's now about dissemination out to sub-communities to implement some of these FAIR principles. And so part of that implementing out is this idea of fairification. And so the Go Fair community has this graphic that sort of talks about the three pillars of fairification. One of them is a cultural change, so changing any culture in education or research around data practices in science, doing science. Then there's Go Train, the actual training of people to actually implement and use Go Fair practices and principles. And then there's Go Build. So a lot of this involves technology, especially with the science gateways. This is something that many of you are likely familiar with already. And so alongside of this is this idea of open science, right? So a lot of this idea of FAIR came from this idea of the replication crisis and the idea of opening up science. And so this little graphic is meant to illustrate sort of the what, where, and the who of open science and education. So on the left, you have open products, and this is actually using a graphic again from Go Fair, where it's meant to illustrate this tight integration between, in this case for education, OER, open education resources, data, and tools or software that accesses and uses that data. And you can also think about replacing OER with research products as well. It could be a research paper or anything like that. But again, this idea being that there needs to be this tight integration between the products from research and education, the data, and the software tools. In the middle are the open service providers. So thinking about the gateways, for example. And I have them sort of artificially split between this idea of an education gateway versus a science gateway. But of course, they're linked and holding hands in the middle, meaning that they get along pretty well. But they're basically providers that, like cyber infrastructure, that has a lot of the tools that support open science. And then on the right, we have open practitioners, learners, educators, and scientists, and is the left one in the Venn diagram, and on the right is meant to illustrate that it can be highly disciplinary, and that it's important not to necessarily ignore disciplinary practices, because you'll have different cultural uses of data and different ways that they deal with it. And of course, in the middle there is supposed to represent math and computer science, sort of like as a central key point. And so there's a lot of stakeholders here, right, that span a lot of different areas. And so one of the things that Sam and I in particular are very interested in exploring is this synergistic relationship between open science and open education. Many of these, the open science communities and the open education communities have been working in parallel and maybe not so much aware of what the other one is doing. As an example where we think and feel that open science and open education really has a fruitful area of collaboration is based on evidence-based pedagogy pushes that have pushed education closer to research. And some examples of this are in bullets here. Universal design for learning, active learning, inquiry-based learning, and course-based undergraduate research experiences all are pushing students away from textbook memorization and closer to actually doing science in the classroom. And so any type of fair practices that are happening in the open science community, we feel it would be great to have some feedback or synergistic building with the open education community as well. And so a lot of the questions that you'll be seeing for the open forum are going to be based on this type of integration. Okay, so I'll kick it over to Sam to do brief introductions and go into the Q&A.
Okay, found my mute button. Hi, I wanted to say thanks for the invitation and thanks for people showing up. So thanks, Drew. That was a great introduction. This is really something that we're just beginning to sort of open the box on. And of course, as you know, as science resource providers, it's a really deep lake to get into. And so in order to facilitate the conversation, I thought it'd be helpful if we just had a little sense of who was in the room so we know where the expertise is and what people's interests are. So if we can do brief introductions, then we'll move into some discussion questions, and maybe you have some questions as well. So I would say I'm Sam Donovan, and I'm at the BioQuest Curriculum Consortium, and we work primarily with undergraduate STEM educators. And we provide both computing tools and open education resources library. Uh-oh, I'm scaring people away with the introduction. And we are tracking FAIR, but we really haven't integrated it fully into our infrastructure. And so that's part of why we're doing this exploration. And I'm going to call on Lee for the introduction.
Whoops, me? I'm sorry. I'm currently working with Symiode, and my name is Lee, and my relationship with FAIR principles.
Oh, Lee, you got real quiet. Are you covering your microphone?
I shouldn't be, but my fan is probably on my computer. That could be causing.
No, okay. Sorry, I just want to make sure we heard you.
Okay now? Yeah. Better? Okay. So my relationship with FAIR principles. Well, I'm aware of them, and I think I know that last year at Gateways there was somebody who was quite concerned about them, and so I read some background on the FAIR principles. So I was just curious what you guys were going to talk about, so that's why I'm here.
Thanks for coming, Lee.
Christopher?
Christopher, I think you're still muted. There you go.
Okay. Good morning. My name is Christopher Buck. I'm a senior engineer, computer science double major at Jackson State University. I'm a student.
Excellent.
Welcome.
And are you learning about FAIR principles in school?
Not yet. Maybe in graduate school, which will be approaching very soon. I only have 3 more classes until graduation.
Fabulous. Congratulations.
Congratulations.
Thank you.
Yeah. One of our agendas is to think about ways to integrate some of the FAIR principles into undergraduate educational settings where students are working with data, like course-based undergraduate research experiences or citizen science projects that are linked to formal education settings, or even data science education, right, where these principles should be addressed some. Mark, you want to introduce yourself? This is really bad to call people out if they're not home. All right, we'll come back to you, Mark. Wai-Yin, you want to
Hi.
introduce yourself?
I'm Wai-Yin. I'm a software developer interested in informal education and community science. And I've had two careers, one in art and one in computer science. And I got through both of them, started as a hobby, and then I turned it into a career, hence my interest in informal education. And both of those were based on doing it instead of reading textbooks, which is
Fantastic.
covers what you cover.
Yeah.
And I'm trying to get into science, but it's hard because it's still, for people not in academia, it's really hard to do some real science. So that's my interest.
That's great. Welcome.
Thank you so much. Yeah, and we've talked before.
Yes.
And Alex, you just joined us. We've had the intro part. I'll repost the link to the slides, but we're just figuring out who's in the room so that we can move into the discussion portion. You could just, if you see, we're just asking for names and affiliations and take on FAIR.
Sure. Oh, I'm Alex Pacheco. I'm the manager of research computing. And for me, I wanted to know more about FAIR principles and how we can help with data management plans. So I help the university librarians with putting together data management plans. So I'm more interested in figuring out how that lands and how HPC as a unit can help non-HPC faculty with data resources.
That's great. Thank you very much. Glad you're here. Okay, Mark, if you're here, you're welcome to chime in. Thanks to everybody. I'm a teacher primarily, so this pulling people out and getting them involved is part of what I do. Drew, could you advance the slide one for us?
Yep. Well, maybe.
So,
there we go.
So we all have, particular projects and responsibilities in different audiences, but this sort of awareness and interest in FAIR, and I'd say we're in the same exact boat. We have some really deep challenges in order to think about what it means to integrate open education resources with data sources and with coding tools and scripts and so forth. And so our push on that is we're actually submitting a proposal to NSF in this FAIR OS RCN call. It's coming up quite shortly. And our goal is to do some of this capacity building for the integration of FAIR OS practices across research and education. And so I guess we're interested to hear if people have any experience training others in OS or in FAIR OS principles and practices, or if people are aware of barriers to adoption. And I know, as Drew mentioned earlier, it can be highly community specific, right? So certain communities play a big role in establishing the culture that acknowledges or creates FAIR resources. So our strategy for building capacity across education and research is to try to emphasize the alignment of research and education. So in undergraduate STEM education, there have been a lot of calls for higher integration of actually doing research in classrooms. And I mentioned before, 3 of the contexts where that's emerging most rapidly is in course-based undergraduate research experiences called CURES. So this is often a faculty member's research area that gets sort of streamlined into a laboratory course that runs for a semester, and students participate in data generation and analysis and conceptualization. But they're doing it in the context of addressing research questions. And so we're interested in how could those groups leverage existing research data to add to their analysis, right? To build up their data sets, and how can they contribute to research data sets? And in order to do that, there's going to have to be a lot of talk across systems that are at totally different scales, because the students are generally working at institutional scales or sort of small gateways, whereas many of the data repositories are in much larger, more highly structured settings. A second area where we see a lot of potential for overlap is around citizen science use. So there's a push again towards authenticity in STEM education to engage students in data collection projects that are sometimes national or international. And there's been some nice research published about how challenging it is to keep those data sets organized and accessible and make them as sort of robust as possible. And then the third theme that we're hitting on is really data science education, where the focus is on extraction, manipulation, visualization, cleaning, all those things that we need to learn to do with data, hopefully as undergrads. I'll just stop talking for a minute and hear if people have any examples or suggestions or ideas about what barriers might be to promoting this kind of integration.
The first question, what you're talking about, some of the barriers. And I think the biggest thing that I've seen, at least at NCSA, is many people know what open source is. That's pretty standard understanding, but not many people understand or know what FAIR is. Whenever you're trying to get adoption of practices within research and education, they're more familiar with adopting open source practices for their code, but that's all they know about.
Yeah, thanks, Shannon. I think awareness, and again, we're talking across, we're trying to integrate vertically people who are in very different relationships with FAIR, right? From scientific service providers, people who are actually building the infrastructure that supports FAIR principles, all the way to what we might call end users in terms of students or faculty who are teaching those students, who are benefiting and maybe need to sort of communicate about how they're able to benefit, understanding the culture of science and so forth, but they're not really building that infrastructure, they're just utilizing it. We think some of the biggest barriers are in the education service providers. So they're sort of scholarly approaches to undergraduate STEM education are really burgeoning right now, right? There are some more journals, there are more places to publish your materials. People are starting to put teaching scholarship on their CVs and things like this, but it's really the Wild West out there in terms of how the data are tagged and passed around. And I think you're right that awareness is a big challenge, but the this education service providers are really where we're targeting some of the action, because they have to implement the tools that will make that data and the scripts and the lessons findable.
Yeah, and I think that speaking to the cultural thing too, like I think you're seeing the shift happen, but making sure that data and software become more first-class citizens with research scholarship, I think is really important to really motivate people to, do all the extra work that they would need to do to make things more findable, accessible, interoperable, and reusable, right? So for data, for example, I know that, even in my own institution, I know I have some colleagues where they have all this data, they come in from the field, and they just have it all kind of in this siloed firewall behind everything. It's closed. They don't even, and there's not enough metadata there necessarily so that it can be actually used by others once they hit publication, right? It's still even, I think, a barrier to, I think a lot of faculty still doing research are like, I don't want to share my data. This is a gold mine for future papers, right? So there's still a cultural challenge there. And so just thinking about, well, if I did share my data, what would I need to do to it to make it actually usable by others is something that, you know, I think is going to require some work.
Yeah, just to build on that a little bit, Drew, the notion I was suggesting that undergraduate STEM education scholarship is sort of emerging. There's been a real change. So for 7 years, we ran an NSF funded project called Cubes that was creating a repository for open education resources and supplying computing tools and so forth. But initially 7 years ago, when we started that, open education publishing amongst faculty was really not looked upon favorably. People were, you know, they had all the sort of standard peer-reviewed expectations. This is going to be out there forever. They didn't understand versioning. They didn't understand adaptations or forking. And so we had to do a ton of cultural work just to explain why sharing a good outline or a draft is valuable, or adding value to somebody else's material benefits the whole community. And I think FAIR comes from that same position, but it's a little bit more technical. Drew, can you push us on to the second question?
Yep. One more thing I wanted to say, Wyan in the chat said, the emphasis on following FAIR principles can vary a lot based on journals, funders, and lab advisors. So yeah, you could get a lot of heterogeneity in terms of which groups might feel FAIR is more important, or even how they approach it, which I think is one reason why Go FAIR and some of these other like top-down places exist, where they try to collect all these principles and standards and verification processes that people can apply to their own situations to try to make it a little bit more homogeneous. Yeah, it's a great comment.
Great comment. I'm going to say just a little bit, and I'm going to really invite some questions here or comments. One of the major drivers that we see, I mean, of course, we want data to be accessible, and we know that the primary goal in NSF's agenda is to increase the sort of the reach of research and the speed of knowledge generation. But we think that FAIR can also be applied to a real challenge that we have in the workforce, which is underrepresentation of groups in both in graduate school and in academia and in careers that involve technical work. There have been some pretty strong papers saying that, look, if you give people projects that are connected to their communities, that that they can have ownership over, and that they're doing actual analysis and work and producing real products. In other words, they're doing science-like activity. You can keep them engaged, and you can draw them into further technical training and, you know, potentially graduate school. So we're very interested in thinking about how the infrastructure can support groups that have been traditionally marginalized, so that the data and the technical skills are really able to raise all boats. So I'd love to hear any examples or counterpoints or suggestions around that.
It's Yin. As a software developer, I've mentored informal learners from underrepresented groups in hopes that in helping them to become software engineers. And when, like you said, the first thing I tell people once they learn the basic coding of what's a loop, what's, you know, basic stuff like that, then do a project. That's what we always tell them. Do a project to make sure that they're interested in this subject. And if they are interested, it will make them learn even more. So I agree with your point that it's project-based. And as software developers, we need data to make stuff. And right now, so when people are looking for open data, they might grab Twitter data or movie listing data.
Right.
So in terms of making data open in order to get people from underrepresented groups into STEM, I completely agree with.
Yeah, that's great. You think of those Kaggle competitions and everything that have sort of, they're not toy data sets, they're big, but they're sort of generic, right? The idea is that it's a place to work with the data. You're practicing your skills, you're not actually producing disciplinary knowledge. So there's some trade-off there. Any other examples that people are aware of or suggestions for strategies to think about equity at the level of using fair practices to make sure that access to the technical skills are widely distributed?
One issue is that with data is that you need a good internet connection and you need a decent computer, which not everyone has. And I don't have an answer for that. It's like, yeah, I don't know how to solve that.
Yeah. Well, so that's sort of a more technical question. And I'd like to follow that. Drew, can we go to question 4? You know, some institutions might be under-resourced, some faculty may not have the capacity for setting up local servers, and there may be security issues and so forth. So what kinds of technical approaches might close the gap between research and teaching in this sort of fair perspective? And Drew, I'd invite you to mention things like nano publications as a potential strategy for that. And what was the other one about? You publish the metadata and don't worry about the repository, people just harvest it.
Well, so this particular, but this is question 4, which is about education and research communities across wide funding availability, right?
Right.
Yeah. So what comes to mind for me without this is this idea that, you know, I remember whenever COVID hit and then people were wanting to, everyone said go virtual. And a lot of the researchers in my department were like, well, we can't meet in the lab, so let's do a lot more quantitative type work with our students. But then that meant, okay, well, now we need to have access to Jupyter notebooks and things like that. So where do we go for that? And so then it was like, oh, well, let's just turn to the IT department. And so my concern is like, well, what, you know, are all IT departments available and ready to go to be able to offer students, you know, this ability to have locally run RStudio servers or Jupyter Notebook servers and things like that. So for me, in this question, that's what really comes to mind is, how, you know, is there a way to, like, if there's no IT department, how can we offer these services to students? And what if you're not involved in academia, right? If you want to have the citizen science, or you want to have the people that are like outside of academia, but you still want to have lifelong learners, where do they go, right?
So again, welcoming examples where high performance computing has sort of made itself available in a successful way to higher education or public service groups, or other strategies for sort of lowering barriers to participation from teaching communities.
Oh, and back to your other question about nano publications. Yeah, so one of the things that I'm curious about is, you know, a lot of educational resources are based on scientific papers or scientific data even, right? And they may, you know, take scientific data and they may simplify it for educational use, but I feel like there's no metadata or ways that there's no metadata that links them together. So you have the scientific product and you have the education product. You know, so, you know, what about these linkages between open education resources, research products, data, and software, like how they connect in capturing what's using what? I feel like there could be a lot of work done to create some metadata for that can be harvested so you can kind of see how these things are interacting, and it would make findability and accessibility, I think, a lot better and interoperable between them.
I've got a non-comment, if I can make a comment. It's probably
hey, Mike,
a comment though. Hey, in a lot of these forums, we spend a lot of our time talking about how do we do fair? How do we make things fair? But we don't often spend a lot of time talking to people who would have some application for fair, right? Everybody agrees it's great to have metadata available and easily findable and all that, but in the end, who's got the killer application for this? And I have a feeling that until we identify some of those killer applications, we're always going to be struggling trying to create technology without necessarily knowing how it's going to be consumed. And I'll give you like a case in point. We, and the Gateway Institute, we spent a decent amount of time talking about what would it mean to have interoperable gateways, right? And invariably, you get into the camp of computer science people who think about APIs and services and all this kind of stuff. But you don't get into the community of people who are doing like multi-scale modeling that would say, yeah, if only I had this molecular simulation of melting point, then I could plug that into this other thing that I'm doing over here that then plugs into that other thing, I could really solve a world problem. And I don't see like this major suite of those kind of challenge applications to be solved by FAIR in proportion to the amount of time we spend talking about trying to make things fair. Does that make any sense, or is that like
that makes total sense?
Space?
So if I can try to read it, it's so it reminds me of, yeah, it's like a what's the use case? Right? You want to get some use cases, and if you have the if people can see the value added to their whatever it is that they're doing of FAIR principles enacted, then that would get a lot more buy-in, I would imagine. Is that kind of what you were addressing?
I think so. It's not necessarily that it would get buy-in, but it would help define what FAIR really looks like, right?
Yeah.
I mean, we've come farther than, I don't know, Dublin Core or something like that, but
right.
Are we really where we want to be? And we met a lot of resistance from the computer science community that our feeling was that applications need to be interoperable, not modules of software. And that was surprising to me that not everybody in the world would see that as obvious.
I agree with you.
Well, I think that reinforces the idea that FAIR really plays out in different ways in different communities, right? So you've got some disciplinary norms. You've probably got norms in terms of funders and publications that are mandating certain principles of fairness. And I think, Mike, you've really hit exactly what we're trying to do with this community that we're going to propose to build, bringing the users who don't even know that they're users really, right? Sometimes into contact with the service providers on the science side, so that we can tell our stories of, I mean, we're educators, we're using smaller data sets, we don't have all the technical skills, but we have a lot of users. I mean, there are going to be some real scaling issues when you start hitting intro bio classes onto somebody's servers. I've broken a few when I was teaching, and so sort of thinking carefully about what's the opportunity space. And it's very uneven in undergraduate STEM education. People doing bioinformatics education, they are essentially out there, struggling themselves to figure out how to bring these resources to their students. And unfortunately, a lot of times they dumb them down because accessing the data is not easy enough for the students to do it itself. And I think that really undercuts some of the messages. And so trying to get those people together, people who are teaching genomics courses, or again, these course-based undergraduate research experiences where they're collecting and analyzing genomic data. that's a great use case that really should be addressed up and down, from service providers in education to service providers on the science side to support staff in the libraries and IT institutions. So thanks, great comment.
You want to jump to the fifth one? So if we have about 5 minutes left.
Sure. I can't remember what it is. So maybe just a show of hands or thumbs up or something. Are people familiar with the Go Fair organization, from which we've borrowed this 3 pillars of any kind of implementation, right? That you have to build it, you have to use the technology effectively, and then you have to train people to use it, but just making the tools doesn't do it, and just training them, you really have to build culture change. So these 3 pillars of go build, go train, go change. Examples where you've seen that done effectively as new resources are rolled out to a community, or obvious points of failure where things aren't attended to, they break down. So, or do other people use these markers to think about the way that they're rolling out their resources? Okay, not seeing many thumbs up there. We really like it because as an education service provider, it's really about changing the culture amongst faculty, which can have a huge impact because of the reach that they have with students. And then they're setting the culture for their classrooms. So our primary claim is that if we make the access to data and computational resources more transparent and facilitate the use of those resources, then it will, with coaching, help faculty engage students in totally different ways in an educational setting, and hopefully help those students have a better sense of what science is and what open science is. So I'd be very interested to hear if anybody has experiences with trying to roll FAIR technologies out or convince people to contribute or adopt. All right, Drew, it's back to you.
Got some comments in the chat. What would be a couple of starter projects for students to take on in order to gain more exposure to building up their skill sets? That's one question. And then YN is another one. NASA transformed open science. Oh yes, that's right. So this is we were made aware of this as well just a couple of days ago, that NASA is also tackling inclusive open science as a really important topic. So Christopher, when you say a couple of starter projects for students to take in order to gain more exposure to building up their skill sets, do you mean in terms of data skill sets, or do you mean in terms of FAIR principles?
Well, I'm not really getting the type of education in my classes, so basically entry level, just get more exposure.
Yeah, I totally agree. And I'll tell you a couple of things that I do that are really not that difficult, right? When I send students to work with a data set, I point them to the metadata, and they have a set of questions they have to answer by reading over that metadata. For most of them, most of the time in our instructional strategies, we're really focused on, can you build the visualization? Can you do the statistical analysis? Can you make the model? But there are very easy opportunities to make sure that students are sort of connecting those detailed activities to the broader context, right? Who generated this data? Under what pretense did they generate the data? who's storing the data? Who's paying to store the data? How do I, what are my responsibilities when I download the data in terms of resharing or citing the author and things like that? And they're kind of techie, detailed things, but these are practices that we have to build and reinforce, starting in undergraduate settings, I think. So thanks for your comment, Christopher.
I want to jump in and let everybody know that it's time, 1:45. So just wanted to thank everybody for coming. I do believe there are closing remarks happening pretty soon. Is that correct, Shannon? I think Cindy's back.
I'll link it shortly, sorry.
Oh, great. No, that's great. Will you put it in the chat for us? So we just pop over.
Sure thing.
And I'm going to put my email in the chat if anybody wants to reach out or share these slides with somebody in your organization who is connected to these ideas. We're very interested in chatting with people. I can't type and talk at the same time.
Well, thanks again for coming, everybody.
Thanks, everyone.